This is Mr. Campbell. This is topic 1A, lesson 3, symmetry in behavior, maximum and minimum. First is respect, symmetry with respect to the y-axis. So for example, let's take a parabola, which is, if you remember, 1, 1, 0, 0, 1, 1, 2, 4, 3, 9, and then reflected across the y-axis, which should tell you right there is reflected across the y-axis, so 3 over this way. And then we draw a graph. Looks like this. Let me do those points with different colors so you can see them. That's there, and then let's outline the graph a little bit. Okay, so how you tell it has y-axis symmetry is if x on the anywhere on the other side is negative x. So for example, this point right here is the ordered pair 2, 4. Notice on the other side another point is 2, negative 4. This right here tells you that it's got y-axis symmetry, and you can tell that that the y-axis, that if you folded it over, those points would land on each other. You can also tell, like if I put another point symmetric, say I take the same point and put it symmetric to the x-axis, well, that would be 2, negative 4, which is down here, and of course that point is not on the parabola anywhere else, so you see right now it's not symmetric about the x-axis. If you, for example, did a circle, well, let's do an ellipse. An ellipse is kind of an egg-shaped looking graph. Okay, so let's pick a point on the graph. This one here, this is not the best example because it's got all symmetry for x and for y, but if I pick a point anywhere, and I'm just going to pick a point right here, which is the ordered pair 2, 0, and you should notice again, I don't know if this was the greatest example to use, but this point right here is negative 2, 0, and of course you can't negate 0. But let's pick this point right here, which is it's not exactly 1, but we'll say it is, okay, just for that this is 2, 1. Then we know over here should be, which it is, 2, negative 1. And notice, negative 2, 1. I'm sorry, negative 2, 1. This is negative 2, 1. So they have, notice the x's are negated, and that's y-axis symmetry. And you can see that you could fold it over the y-axis because it has y-axis symmetry. Now, this one here also has x-axis symmetry, and we'll talk about that here in a few minutes. Now, so for it to have y-axis symmetry, if you take any x and do another point across the y-axis, then that other point should be negative x. Now the next one is symmetric with the origin. if it's symmetric with the origin, symmetric with the origin, then both of them are negated. X is the opposite of x, and y is the opposite of y. So for example, let's do the cube root, the cubic one, which is 1, 1, 2, 8. And of course, -1, -1, -2, -8. Okay? And we draw our cubic, not cube root, cubic. So let's pick a point. Say that's 2, 8. 2, 8. If you remember, we just talked about that if it's symmetrical about the y-axis, then 2, -8 should be on the graph. And notice it isn't. If it had x-axis symmetry, which we're not really emphasizing, then -2, 8 would be on there. But of course it's not either. But if it's got origin symmetry, then -2, -8 should be on the graph, and it is. Notice we negated both of them. Another way to look at it is if I take this point and I reflect it across the y-axis, which would put it over here, and then reflect it over the x-axis, then it would put it down here. And I could also do it like this. I could reflect it across the x-axis and put it down here, and then reflect it across the y. What it ends up being is you're taking this point and you're moving it 180 degrees. That's what origin symmetry is. So if it's symmetric with the origin, you negate both, take the ordered pair, and negate that ordered pair. And those ordered pairs that you got after you negated should be on the graph. If I take the cube root, which looks like this, 0, 0, 1 cubed is 1, 8 cubed is 2, and then -1 cubed is a cubic root of -1. So I'm doing this function right here, the cubic root, not the cubic root. -1 cubed is -1, and -8 cubed is -2. The cube root of -2. So then when I graph this, okay, so if you look, this point right here is 8, 2. Then if you'll notice, -8, -2 is also on the graph. This point has been moved 180 degrees. Okay? Notice if we thought this thing had y-axis symmetry, then this point would be over here, and of course there's not a point on the graph over there. If we thought it had x-axis symmetry, that point would be right here, and of course it's not on the graph either. Again, think about it. For origin symmetry, you're going to reflect it across the x and then reflect it across the y, or you could reflect it across the y and then the x. That ends up being origin symmetry. Okay? In behavior, okay, as x goes left forever, and we're talking about x is left forever, we're talking about as x approaches negative infinity. So we're going to the left, we're on the left side, and I'll abbreviate it now. So we're over here, we're looking at what it does on this side. We're going this way. So as x approaches negative infinity, then what is y doing? If you notice, it's going this way, it's going down that arrow. It's also going to negative infinity. It's going down as well. It's getting smaller. As it goes to the right, which means x is approaching positive infinity. Notice I didn't put a plus there. You could if you wanted to. So now I'm looking at the end behavior here. The y is going up, so it's also going up. It's also going towards positive. It's going towards positive infinity for this graph. That's what it means. in behavior. Okay, this one here. There's the farthest left side. As again, we're doing the left side, and then we'll do the right side. The left side, of course, as x approaches negative infinity. We're going, as x goes this way, then y is going up. So y is going towards positive infinity. And if you look on the right side over here, as I go this way, as x approaches positive infinity, okay, kind of get cut off there, then what's y doing? It's also going up. So it's going also towards positive infinity. They both were positive. This next one, as x goes left, so we're going left, we're working at this one here, we're going this way. As x gets smaller and smaller and smaller, as x approaches negative infinity, what's y doing? Well, y is going up. It's also going towards positive infinity. It's getting bigger, but x is getting smaller. And then on the right side, as x approaches positive infinity, it's going this way, y is going down. So y is going towards negative infinity. It's getting smaller. So the arrow's going down. Now this one here got cut off, so I'm not going to worry about it. I don't know what it was, so we'll just skip it. No big deal. So that's in behavior. Now, let's talk about the absolute max and min of a function. Is the largest and smallest value for y of the function. The relative maximum and minimum of a function is where the point where the function changes direction from increasing for y to decreasing for y, or decreasing for y to increasing, but not necessarily over largest or smallest value of the function. So for example, as I go this way, as I go up the mountain, which means x is increasing, what is y doing? It's also increasing. Okay? So as we get up here, this is a maximum value. So the max for this one here, y has a value of 3. So it would be the 0.43. When they talk about the max or the min, it's the y value, the biggest y or the smallest y value. In this case, it was 3. This one here has 2 minimums. Notice these are both low points. You're going down, and then you end up going up. And then this point here, this one right here in blue, is a maximum. The 2 in green are minimums. So we have a minimum value at -1, -3. And also at +1, -3. So our minimum value would be -3 because it's the smallest value, y value we got for the minimum. The maximum is the ordered pair 0, 0. Is 0, 0. And so it's right here. Notice we're going up this way, and then we're kind of going back down. These other ones we're going down and then up. That's what gave us the minimum. So the maximum value would be 0. Make sure we've got all this here. Yep. Okay, so let's talk about a linear function. Remember, linear is y equals x. So if I draw my line, goes through the origin, Lines should always have arrows on the end of them because they don't stop. So what kind of symmetry does it have? You should see that it's got origin symmetry. Well, let's check it. Let's pick a point. 1, 2, 3, 1, 2, 3. 3, 3. Well, is negative 3, 1, 2, 3, 1, 2 is negative? It sure is. There's the other point on the graph I picked. Negative 3, negative 3, which is the negation of both of those. It's in behavior on the left side, which is on over here, the left side. That means as x approaches negative infinity. Well, you'll notice right here, y is also going down. So y is also approaching negative infinity. Okay? And the right side, that means x is approaching positive infinity. On the right side, y is going towards positive infinity as well. This thing here does not have a max or min value in A. It doesn't have a hump anywhere. Okay? Quadratic. So 0, 0, 2, 4. I just use those because I don't have a lot of room to work. 1, 2, 3, 9 is right there. It's all reflected across the y-axis. So it looks like this. Okay, so it asks for first symmetry. Well, this here, the point is 2, 4 on this right side. Well, negative 2, 4 is on the other side. So that tells me it has y-axis symmetry. Why? Because x, I get negative x. I negate the point that I pick. Any point you pick, then another point on the other side of that axis should be the negation of x. Okay? And our right side, our left side behavior, so again, left is always x approaches negative infinity. Well, y is also approaching positive infinity because it's going up right here. On the right side, which is always x approaches positive infinity, then y approaches also positive infinity because it's going up here as well. It has a minimum value because this is down here, isn't it? It's got a minimum value of 0 at the ordered pair 0, 0 at the point 0, 0. The cubic function, quadratic, I didn't write that down, y equals x squared, and the cubic function is y equals x cubed, so we have 0, 0, 1, 1, 2, 8. And then negative 1, negative 1, and negative 2, negative 8. So it looks something like this. Okay. Alright, so let's look at first the symmetry. Well, I'm going to pick this point, which is 2, 8. And notice that if I put it over the y over here, is negative 2, 8 on the graph. No, it is not. If I go across the x-axis, which I didn't really talk about this, but then it would forbid to have x-axis symmetry, then you negate the y. So it's 2, negative 8 on the graph, and it's not either. However, negative 2, negative 8 is on the graph. I negated both of them. So it has origin symmetry. Origin symmetry. Why? Because we negated both x to opposite of x and y to opposite of y. Those ordered pairs are the same. You negate both of them. Okay, so now our left side behavior, that means I'm going towards negative infinity. So y is going down over here, isn't it? Right there. So y is going towards negative infinity. My right side, that means x is going up, or going towards positive infinity. My y is also going up towards positive infinity. This one here does not have a max. It looks like there would be one at 0, 0. But for it to be a min or a max, it's going to be going down and then it's going to go back up. Or it's going to go up and then it's going to go back down. So that doesn't make work. So this one here is NA. Okay? Absolute value function. So absolute value is like this. V shape. Okay. Okay. So it wants to know first the behavior, correct? Or does it have origin, symmetry? Well, this one here, if you look at it, this is the ordered pair. I'm just picking these now. 5, 5. Well, you know right now from looking at it that 5, negative 5 is on the graph on the other side. So if x goes to the opposite of x, then you know it has y-axis symmetry. So on the left side, which again, that means x is going towards negative infinity, that never changes, then y is going up, isn't it? It's going towards the ceiling, so y is going towards positive infinity. On the right side, that means x is approaching positive infinity, and y is also going up over here, isn't it? So y is approaching positive infinity. This one here would have a minimum at 0, 0. So my minimum value would be 0. Remember, your minimum value is your y coordinate, the y value for the minimum. Square root, so we got 0, 0, square root of 1 is 1, square root of 4, 1, 2, 3, 1, 2, 3, 4, 2, and 9 3s right here. So let me give you those ordered pairs. 0, 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Okay? So this one here does not have any symmetry. None. Okay, let's find a point. If it had x-axis symmetry, it'd be over here, wouldn't there? Is there a point on the graph over there? Nope. Over here, there'd be a point, wouldn't there? 1, 2, 3, 4, 2. There'd be a point over there, and it's not on the graph either. If it had origin symmetry, this is 4, 2. Then negative 4, negative 2 would also be on the graph, and it's not. So this one here is none. On the right side, excuse me, on the left side. Let's do the left side first. The left side is the point 0, 0. So x is approaching 0. As x approaches 0, y approaches 0. On the right side, x is approaching positive infinity. Then y is approaching positive infinity. It's also positive. This one here has no maximum or min because it's just going up to the right. There's no change of it going up and then down or vice versa. Exponential, remember we're going to use y equals 2 to the x. So let's do some ordered pairs here. And then 0, 2 to the 0, anything to the 0 power is 1. 2 to the first is 2. 2 squared is 4. I could do 3 is 9 too. Negative 1, that means 2 to the negative 1 power means 1/2. And 2 to the negative 2 is 1/4. So let's graph this thing. 0, 0. 2 to the first is 2. 2 squared is 1, 2, 3, 4, and I'm going to go ahead and do, I didn't do this one, I'm going to do 2 to the third, which would be 8, which is right there. And I didn't graph that one right, that should be the one there, shouldn't it? Yep. And then negative 1's 1/2, so it's getting really close to the y-axis. So as x approaches, we're going to the left side now, as x approaches negative infinity, then y is approaching 0. On the right side, as x approaches positive infinity, y is approaching positive infinity. They're both getting bigger. I flipped these two around. This should have been my end behavior. This one here has none. No symmetry. There's not another point on the right side, there's not another point on the left side, and there's not another point 180 degrees around. So this one has none. I better do this. Better put them in the right spots so I don't confuse people. So this one here did not have any symmetry. And then as x approaches positive infinity, then y is approaching, this is on the left side, y is approaching 0. And to be honest with you, they're both approaching 0. They're both getting really, really close to 0. On the right side, x is approaching positive infinity. Y is approaching positive infinity as well. This one here does not have a max or a min. Okay, cube root, which is y equals cubic root of x. So 0, cubic root of 0 is 0, cubic root of 1 is 1, cubic root of 8 is 2, so I use these ordered pairs. 0, 0, negative 1, negative 1, negative 8, negative 2, and then positive 1, 1, and positive 8, 2. And you can see right now this one here is going to have origin symmetry because you look at your ordered pairs, you have negative 8, negative 2, and down here we've got the negation of both those two, so that's going to be origin symmetry. So it looks like this. So as x approaches on the left side, means x is going towards negative infinity. Y is approaching also negative infinity. It's going down right here. And on the right side, x is approaching positive infinity. Y is approaching also, it's also going up on this side. And then it asks for, it doesn't have one. For it to have a max or a min, it's got to be on going down, or either going down and then up, or up and then down. I think that's it for this part. We do have some examples here. Let's see here. Example 5. I don't think. I think this is the next part. I don't think we're going to have to. This is the next unit. Let me check just to make sure. No, it's part of the unit. So let's do this. Okay, so this one here is absolute value function. And you should see that x is on the outside, so that means I'm negating the y, which means I'm reflecting it over to x, and then I'm moving it down 2 units. So here's our parent function. Here's our parent function right here. I like to do it in dashed. And then I'm going to reflect it, because the negative, I'm going to negate the y's, which means I'm going to reflect it over the x-axis, and then I'm going to move it down 2 units. So when I reflect, this point here will be here, and then I'll move it down 2 units. So it's going to be here, and I'll move it down to 2 more units. So let's see if that works. Okay, you should do your operations from left to right. So I shifted, I reflected it, then I moved it on down. This right here tells I move it down 2 units. So really it should be here. So let's see what happens. I'm going to put in 1 for absolute value of x, and it does work. If I put in 1, into this function, I better get -3, which is what I get right here. That's -1, -3. So now I can draw my graph from those other points. I can reflect those other points and then move them down 2. And then draw my graph. So it looks like this. I'm going to do a solid so it doesn't look like the parent function. Okay, so if I look at my end behavior, x goes to negative infinity, then y is also going down, so it's going towards negative infinity. On the right side, x is going towards positive infinity. Both these, this is negative infinity here on the left side, so this is left, this is right. And then y is going down as well on the right side. Symmetry, the new thing has no symmetry because it was shifted. If it's ever shifted right, left, up, down, you're not going to have symmetry. So none. And it does have a maximum, and that ordered pair is 1, -3, So my minimum is -3, because that's the y value. Does not have any minimums. Okay? This one here is a parabola, a quadratic. Y equals x squared. So 0, 0, 1. 1 squared is 1, 2 squared is 4, 3 squared is 9. So y. Draw my graph. My parent function. Okay. So they want you to shift this thing right 3 and down 2. So I'm going to take this thing here, I'm going to move it right 3, 1, 2, 3, and down 1, 2. So here's where my new vertex is. So then I'm going to take those points and do the same thing. Down 1, 2, 3, and over 1, down 1, 2, 3, and over 1, 2. Down 1, 2, 3. Excuse me. I'm going to take this point and go right 1, 2, 3, and then down 2. Wake up, Mr. Campbell. So take this vertex and go right 1, 2, 3, and down 1, 2. There's my new minimum. Then I take that point right 1, 2, 3, down 1, 2. And this down over 1, 2, 3, and down 2. This point down right 1, 2, 3, and down 1, 2. This point here, right 1, 2, 3, and down 1, 2. Right, this point 1, 2, 3, down 2. So there's my new graph. So as x on the left side, as x approaches negative infinity, y is going up over here, so it's going towards positive infinity. On the right side, x is going towards positive infinity, and y is also going to positive infinity. It does not have any symmetry now. It did at the beginning, but it doesn't now, because I shifted it right, left. It has a minimum value at 1, 2, 3, and down 2, so it's the ordered pair 3, -2. That's where the vertex is right here. So my minimum value is -2. This next one is a cubic. So it was 0, 0, 1 cubic, 1 cube, 2 cubed is 8. And this one here is like this, -2 is -8. So I draw my graph. Let me put those points bigger so you can see them. Like that. I did dash it, but that is the parent function. This one here, you work left to right. So this one here tells me I'm negating the y. So let's take our ordered pairs. And here's our original ordered pair: 0, 0, -1, -1, -8, or excuse me, -2. -2, end up with -8, +1, 1, and +1. 2 times 2. So first thing you're going to do is with that negative is you're going to negate the y value, so the x values don't end up changing at all. Because remember, everything on the outside deals with the y, and there was nothing inside the parentheses there. I didn't have a parentheses. So I'm going to negate all the y values and then move them down 4. So let's do, I'm going to do the negate first. I'm going to negate it, okay? So it's this. So 1, 1, 2, negative 8, 2, negative 8, okay? And then I'm going to move those y values down 4. Subtract 4, so negative 2, 8 minus 4 is 4, negative 1, 1 minus 4 is negative 3, 0, 0, 0 doesn't change, but I'm going to subtract 4, so it'd be negative 4. 1, negative 1 minus 4 is negative 5. And then 8, negative 8 minus 4 is negative 12. Okay, so let's graph this. Negative 2, negative 2, 4. Negative 1, negative 1, negative 1, negative 3, 0, 0, 1, negative 1, let's see what I did wrong here, 0, 0, 1, added 4, so subtracted 4, so 8 minus 4 is 4, 1 minus 4 is negative 3, negative 1 minus 4 is negative 5, negative 8 minus 4 is negative 12. So negative 2, 4, negative 1, negative 1, negative 3, 0, negative 4. That's what I did wrong right there. I knew I'd done something wrong there. 0, negative 4. One, negative 5. There we go. And then 2, negative 12's off the page. Just clear down here somewhere. Can't see it. So my graph's going like this. Now, this point right here is 1, negative 5. Okay? So if I plug it into this thing right here, it better work. So here's y. I'm going to plug in 1 into my equation. Rules of order means 1 cubed. You got to do the rules of operations and then negate. So it'd give me negative 1 minus 4 is negative 5. So it does work. Okay, so now this one here has no symmetry because I shifted it. As x is going from the left side, x is going towards negative infinity, well, y is going towards positive infinity. It's going up right here. As x approaches positive infinity on the right side, y is going down, so it's going towards negative infinity. This one does not have a max or a min. Okay, I think that's it. Oh, we got another one. I don't think all these are on your homework. Okay, this is it's already got the graph for you. They want you to reflect. Now this negative here means I'm negating the x, which means I'm reflecting across the y-axis. So for it to have, when you negate the x, that means it has y-axis symmetry. So x is going towards negative x. So these points that I have here, which here's my word pairs, 0, 2 to the 0. I'm doing the parent function here first. Parent function is this. Okay, 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. 2 to the third is 8. 2 to the negative 1 is 1/2. 2 to the negative 2 is 1/4. Okay, 1/4. So when I negate all the x's, so here's my new function that I'm going to graph. Instead of negative 2 1/4, it's 2 1/4. Instead of negative 1 1/2, it's 1 1/2. 0 1 doesn't change. That makes, instead of 1 2, it's negative 1 2. Instead of 2 4, it's negative 2 4. Instead of 3 8, it's negative 3 8. So I'm going to graph these points now. So 2 1/4 is right here. 1 1/2 is right here. 0 1 is right here. Negative 1 negative 1 2. Oh, they already graphed it for us. What a ding dong. Okay, so we've already got it graphed, which is nice. Okay, so as x goes towards negative infinity, which there's the left side, then y is going up towards positive infinity. Over here, as x approaches positive infinity on the right side, so this is the left side here, here's the right side, y is approaching towards 0. And to be honest with you, x is also going towards 0. So I should have saw that. X is getting closer and closer to 0 as well. So as x goes towards positive infinity, y is getting close to 0. Okay? This one here has no symmetry, and no max or min. Okay? An air tanker flies over forest fires and drops water at a constant rate until its tank is empty. What is the domain and range of the function that represents the volume of a water tanker and drop in X seconds? I'll do this one in class. It's not that important going into your homework. Okay? Thank you.